Hello friends, I am Vikash Kumar. Today, we will understand another important detection subsystem of the MLFF system, the Radar Detector. Radar stands for Radio Detection and Ranging. The radar detector uses radio frequency waves to detect the presence, speed, distance, and movement of vehicles. In the MLFF environment, vehicles travel at very high speeds. Therefore, the system requires accurate vehicle tracking and speed measurement capabilities. To fulfill this requirement, the radar detector is deployed. The radar continuously monitors the road section and detects vehicle movement in real time. Now, let's look at the minimum technical specifications defined in the RFP. Parameter Minimum Specifications. Frequency band 76-81 GHz. Object tracking capacity up to 256 objects. Lane coverage up to 4 lanes. Detection range up to 300 meters. Speed detection 150 kmph or higher. Speed accuracy better than 8%. Measurement parameters X coordinate, Y coordinate, Z coordinate, azimuth, elevation, and speed. Communication interface Ethernet, USB, RS485. Refresh time 24 milliseconds. Power supply 12V compatible. Power consumption 10 to 40 watts. Operating temperature -10 degrees Celsius to +60 degrees Celsius. Protection rating IP67. Certification Government Authorized Speed Accuracy Certification. Now, let's understand what the radar detector actually does. The primary function of the radar detector is to monitor vehicle movement. It performs the following functions. Detects vehicles. Measures vehicle speed. Calculates vehicle distance. Tracks vehicle movement. Monitors vehicle trajectory. Monitors multilane traffic. Supports transaction validation. Now, let's understand how the radar detector works. Step 1. The radar detector continuously transmits radio waves. Step 2. A vehicle enters the detection zone. Step 3. The radio waves are reflected by the vehicle. Step 4. The radar receives the reflected signals. Step 5. The system calculates the vehicle's distance. Step 6. The vehicle's speed is measured. Step 7. The vehicle's movement is tracked. Step 8. The tracking data is forwarded to the MLFF system. Now, let's understand the role of the radar detector in the MLFF system. In the MLFF environment, vehicles travel at high speeds. Multiple vehicles move across different lanes. Several vehicles may pass beneath the gantry simultaneously. The radar detector continuously monitors all these vehicles and provides real-time tracking information. This additional data helps the transaction processing system improve validation accuracy. Now, let's look at a practical example. Suppose 3 vehicles are passing beneath the gantry at the same time. A car traveling at 90 kmph. An SUV traveling at 100 kmph. A truck traveling at 75 kmph. In this situation, the radar detector detects all the vehicles. It measures the speed of each vehicle. It tracks the position of every vehicle. It monitors their movement. It provides accurate tracking data to the MLFF system. Now, let's compare radar with LiDAR. Many people are confused about the difference between these two technologies. LiDAR uses laser technology. excels at vehicle position detection, is highly effective for lane occupancy detection. Radar uses radio wave technology, excels at speed measurement, is highly effective for long-range detection. Both technologies complement each other and work together to improve overall system performance. Now, let's compare radar with the ANPR system. The ANPR system tells us what the vehicle registration number is. The radar detector tells us how fast the vehicle is traveling, how the vehicle is moving. Therefore, the roles of ANPR and radar are completely different. Now, let's look at the key benefits of the radar detector. Accurate speed measurement, long-range detection, multi-lane monitoring, high-speed vehicle tracking, traffic monitoring, transaction validation support, revenue protection, reliable 24/7 operation. Now, let's understand the importance of the radar detector in the MLFF architecture. The radar subsystem improves vehicle tracking, improves vehicle detection accuracy, supports traffic analytics, supports enforcement activities, strengthens transaction validation. For these reasons, the radar detector is considered a critical component of the MLFF detection layer. Now, let's summarize the key takeaways. Radar stands for radio detection and ranging. It uses radio wave technology. It measures vehicle speed. It monitors vehicle distance and movement. It can track up to 256 objects simultaneously. It supports a detection range of up to 300 meters. It supports MLFF transaction validation. Now, let's go through a few interview questions. Question: what is the full form of radar? Answer: radio detection and ranging. Question: what is the primary function of the radar detector? Answer: to detect vehicle speed, distance, and movement. Question: which frequency band does the radar detector operate in? Answer: 7681 GHz. Question: what is the major difference between radar and LiDAR? Answer: LiDAR uses laser technology, whereas radar uses radio wave technology. Now, let's move to the next subsystem. Art. Local server. In the next section, we will understand how the local server acts as the central processing engine of the MLFF system, how it processes transaction data, and how it manages information received from the RFID reader, ANPR-SY. If you found this video informative, please like the video, and don't forget to subscribe to Toll Tech Academy for more technical training videos.